Hi everyone, this is Dr. Marra with Dr. Marra's Medical Minutes, and today we're going to talk about what was on 60 Minutes on Sunday in regards to a brand new study that will be taking place in Nantucket, which is basically considered part of Cape Cod. And as most of you know, Cape Cod is a highly endemic area for tick-borne illness. And in fact, Nantucket is has one of the highest incidences of Babesia in the world, and I think only second to Slovenia. So um, they are doing and designing new research which is going to genetically modify the white-footed mouse, which happens to be the vector for many of these tick-borne illnesses on Nantucket, as well as deer and probably birds and so forth, rodents. But apparently the white-footed mouse seems to be very problematic, and so that's what they're going to use for studying the genetic modification of them so that they don't transmit Lyme disease. It's a really novel way to um, manage um, the problem of Lyme disease that I hadn't really thought of, is to work at the level of the animal reservoir. The vector would be the tick, the reservoir would be the white-footed mouse, and deer, and on and on. But anyways, so I think that this work is encouraging, even though it's very progressive and sort of far out there. I do think that it's going to require innovative thinking and innovative testing and innovative problem solving to figure out how are we going to stop the spread of these awful infections. I've been in practice for 27 years now, and I began in Connecticut with Dr. Horowitz and Dr. Jones, and we would see Babesia maybe one in every 5 or 6 patients. Now it's probably more like one in two, and where Dr. Horowitz is, it's just about everybody. So New York is also a highly endemic place for Babesia. And for those of you that don't know what Babesia is, it's an intracellular red blood cell parasite. It's very similar to malaria. So if you think of the equator as this, above the equator is Babesia, and below the equator is malaria. They respond to the same drugs. They're both protozoans or parasites, and they have similar symptoms. And the concern is that the spread of all of these vector-borne, it's no longer just tick-borne, it's vector-borne. We have spiders, we have fleas, we have sandflies, we have maybe even bees. I'm not sure, but I've always said, even 25 years ago, when they were saying, "Oh, no, it's not in mosquitoes," I knew it was in mosquitoes because um, I had a really good friend of mine who got sick with uh, tick-borne illness, who'd been bitten by like multiple mosquitoes in the Dominican Republic, and she got several tick-borne illnesses, and she also got dengue fever. Dengue fever is difficult to heal, and is it's also vector-borne by mosquitoes. So I think a better way to look at this problem is to say all of these organisms they've been on the planet for a very long time, but the slow and gradual climate change, and you can argue whether or not we're having climate change, but if you look at the data, where the globe is getting warmer, and whether or not it's due to fossil fuels or the natural cycle, it doesn't really matter. The globe is warming. And as the globe warms, these organisms, these vectors and insects, they don't die in the winter because the winter is warm. And so you get constant replication. And that is, I believe, to be one of the problems uh, of sort of the modern day. Um, the other thing is that for most people, the degree to which you attract mosquitoes is genetic, and it has to do with the concentration of carbon dioxide that you breathe out. Carbon dioxide acts as a chemoattractant to mosquitoes, which is one of the reasons why, you go to the beach with four people and only one of you gets, 100 mosquito bites. So that's what we think is going on. So I'm quite certain it's much more complicated than that, but um, right now that's all the information that we have. So I hope you found this information helpful, and I hope you have a wonderful day. Take care.